Okay, everybody. Today's video seeks to find an unknown function from a functional equation. A lot of us are used to getting a number from an equation as a solution or a set of numbers as a solution. But in this particular case, the function is a functional equation, and we're actually seeking an unknown function. Now, this particular problem was worked at the SyberMath channel, and I'm going to show you another approach. Get the same result they got at this channel, but it's a completely different approach to the problem. Now, if you take a look at what's given here, it's a function evaluated at itself, basically. In other words, you have f of x plus f at y, so it's sort of like a composition, but not quite. It's f evaluated at its own output. Now, so what I'm going to do right here is make the assumption that the unknown function is linear. And notice I'm using question mark here as my unknown rather than x or y. Y sometimes is linked with f of x, y equals f of x. So I'm using question mark because it's almost like x is getting overloaded here. Now I'm picking a linear function because if it was a squared function, you would have squared output right up here. In other words, these are all linear terms that I'm highlighting right here. If the parent function f was cubic or squared, you would have squared or cubic terms here. So I think it's completely justified to pick a linear function, a question mark plus b or ax plus b if you prefer. All right. Now what I'm going to do is just carry on here. Here are the steps. I probably can minimize what I say right here, but we're going to work our way through this problem using this parent function, a question mark plus b. All right. So the very first step, it's fairly straightforward actually. If you take a look at f at y right here, f at y, if you substitute y in for question mark right here, you get ay plus b. Okay, so that's one application of the function right there. F at y is exactly what I've highlighted there, okay? But now this trinomial becomes our new input to the function. That's the key to seeing what's going on here. That's the new input to the function. And so what do you do with inputs to this function? You multiply by a and add b, which is what I did right here. Okay, I multiplied our new input, the trinomial. It's kind of cool how this works out. And I added b. So you see the f function was double applied. It was applied to get ay plus b, and it was applied to get this. Now the rest of the problem is just collecting like terms and equating coefficients. So we'll get to this line right here. Now notice, you may think it's superfluous for me to put the ones right here, but 1 is the coefficient of x, 1 is the coefficient of y, and 1 happens to be the constant term here. So you can see you get, it's overkill for a. A is 1 and a squared is equal to 1. See, a squared is 1 and a is 1 if you equate these coefficients. A squared is what's in front of y. Well, 1 is in front of y over here. A is in front of x. Well, 1 is in front of x over here, right? Now, what about this constant term? There's no dependency on x or y in this term ab plus b. And so you actually get, in this, trying to highlight this thing's kind of irritating. Okay, so notice that ab plus b has no dependency on the x or y terms. That makes it the kind of the literal constant term, if you will. So that's why we set ab plus b equal to the constant term 1 over here, which is exactly what we've done here. Okay. Now you see the arithmetic is very straightforward. If a is equal to 1 in this expression, you're going to get b plus b is equal to 2. That's 2b is equal to 2. That's b is equal to 1/2. So just like that, we get a equals 1 and b is equal to 1/2, which means if you take these values and put it into our parent function right here, you get exactly what you see here. Now this looks a little foreign right here to leave it that way. So I'm going to write it in the more familiar expression, x plus 1/2. All right, now the check is easier. Here's the check condition. Again, f at y, right here, that's your f at y. Well, f at y is just that, see? Guys, the highlighting just isn't quite working for me tonight, folks. But this part that I've highlighted here is your f at y. But notice now that is your new input. X plus y plus 1/2 becomes your new input. So x plus y plus 1/2 belongs right there. And again, we're talking about this x right here getting replaced by x plus y plus 1/2. Now, the rest of it's pretty self-evident. So it does check f at x plus f at y is equal to x plus y plus 1 for this is our choice of functions. All right, folks, hopefully that was clear. It's all written down. The talking I was doing, I was kind of stepping over myself there. But you can look at all the steps and confirm that this is another approach. The way it was done at SyberMath was different. He got the very same result, x plus 1/2, but he did it completely differently. So I'm just showing you this so you guys can compare and contrast the two approaches. Thanks.